Alright guys, today we're looking at solving literal equations. A literal equation in simplest form is one where you are solving for a variable, so that's no different than a normal equation, but the big difference is here that you're going to solve for a variable in terms of another variable. Meaning there are going to be multiple variables in the same equation, and you are not trying to solve for all the variables in there. You're actually still just trying to solve for one of them specifically, but the difference is that there are going to be variables in your answer. So let's look at some specific examples in here, and hopefully you'll get the idea. So one specific example, actually first thing we need to cover is getting rid of a term versus getting rid of a coefficient. And if we understand that terminology, it'll be very helpful. For all of these problems, let's, for this one anyway, let's assume we're solving for x. Okay, so if we were solving this for x, the things that we need to get rid of to get the x by itself would be the 3 and the 4y. Notice how I circled the 4y as a whole, because we need to get rid of that whole thing. The 4y is considered a term. Terms are things you add. Coefficients are things that are multiplied by the variable. Okay, so 4 is a coefficient of y, but if we treat 4y like the whole thing, it's a term. Okay, this equation is honestly really just very similar to something like 3x plus 4 equals 7. Over here, we would subtract 4 and divide by 3 to get an answer of 1. The process is really very much the same over here, except this time we're going to subtract 4y. We can subtract the whole thing because it's being added, so it's a term. We get rid of addition with subtraction. There's a small difference here, though, and it's a significant one. We get 3x equals 7 minus 4y is not something that's possible for us to do because they are not like terms. So we're going to have to leave it as 7 minus 4y. The other big difference then comes in when you divide by 3. Instead of dividing, since we want to divide the whole right side by 3 and there are two terms, you can either write it as a big fraction bar with a 3 underneath, or you can simply use the distributive property and write divided by 3 underneath both of them. I would probably leave both of these as fractions, and you could write 7/3 minus 4y over 3, or if you left it as a big fraction bar, 7 minus 4y all over 3. Both of those are very valid answers for x. So we have an answer for x, but there's a y in the answer itself. Why don't you guys try b here? So try b. You're going to solve for c in this one. Try that, pause, and then come back. All right, at this point, I'm assuming you've done that. So we want to subtract 5y from both sides. And then we get 3c equals 12 minus 5y. We want to divide everything by 3. And I get c equals 4 minus 5y over 3. Again, I typically try to avoid using decimals as much as possible because fractions are typically more exact. So, last problem. This one you probably have not necessarily encountered before, maybe not since last year. You probably did when you were studying proportions. The way that we can get rid of the fraction here is through a process called cross-multiplying. Basically, the idea is this. If we had a simple, this is just a side example, if we have something over here that we know is true, what we can do is multiply the numbers on the diagonals, and those should also be equal to each other. So 2 times 2 are on a diagonal, 1 times 4 are on a diagonal, and we know that that is true, and that'll work for any two fractions that are equal. We can apply that same logic over here. Multiply the things that are diagonal from each other. So we get 2x times y equals 3c times r. Now, the issue is that we need to get rid of both the 2 and the y. Well, they're both being multiplied, so we can divide by both 2 and y. Do that on both sides, and our answer is really kind of weird looking, but it really wasn't too bad to get there, hopefully. We get 3CR over 2Y. That's it for solving literal equations. Hopefully you learned something, and we'll talk about it the next time we have class.